Good day, ladies and gentlemen. My name is Mqondisi Macaba from Tembela Maths Club, a club that helps learners to understand mathematics. So today I will be discussing with you a very, very critical topic of introduction to geometry, right? And then this is an introduction. I am going to pretend as if you have never studied geometry in your life, and then I'm going to start you from scratch. This is lesson one of many lessons that are going to come. And then these lessons will be discussing this beautiful topic of geometry. All right. Geometry is a problem for many people. Basically, what makes geometry to look like a problem is because in geometry, number one, it is important to know what is it that you are writing, but that is not all. Secondly, you also have to present what you are writing in a very, very particular way that is accepted in terms of the syllabus that you are writing for. So right now, I will be doing work for CAPS syllabus, and then the reasoning that I'm going to be used is the reasoning that is accepted in terms of the CAPS syllabus in South African schools. So before today's lesson ends, you must be able to answer these questions. Number one, what is geometry? You should know what is geometry. And then what is a theorem? Because people saying, I do not know what theorem to use, because sometimes some of them, they don't even know what a theorem is. And then also how to use a theorem. Okay, now I know what a theorem is. Now, how do I use that theorem? And then lastly, how do I master geometry? How do I put all things together and make sure that the geometry for me becomes a very, very smooth thing? So at the end of this lesson, all of these questions should be answered. I'm going to use the examples from a grade 8 syllabus of geometry. And then if you are doing grade 9, grade 10, grade 11, grade 12, these can help you, especially if you are struggling with geometry. If I'm saying I'm going to use the grade 8 examples, it's because I want to define whatever that I'm going to define in a very fundamental level so that you can be able to understand. Because if you do not understand those simple things that are learned at grade 8 level and how do they come together, then you will definitely have a problem in grade 9. You will definitely have a problem in grade 10, grade 11 also, and also grade 12 and even further than that. So it is very important. So don't hear me saying grade 8 and then you want to run away and say, I don't need this one. No, you do need, because this is very fundamental. Okay, let's check the personalities. Let us go from here. Okay, so question number one, what is geometry? Right, there is a definition of geometry that we can get from a dictionary, a branch of mathematics that studies the sizes, shapes, and whatsoever thing. I am not going to use that kind of a definition. I want a working definition, a definition that we can be able to work with. So basically, when we're speaking about geometry, geometry starts with a point. That's where geometry starts. It starts with a point, and then a point then forms what? A line. Okay, so you've got a point, and then that point forms a line, right? Now, if you can have from the same point, if you can just draw another line, you will get something that looks like this. And then this thing, you can put a protractor here and be able to measure from here to here how many degrees it is. Therefore, you will get something here, a degree from here to here. And what is this? It's an angle. All right? So geometry starts from a point, and then it forms a line, and then you can form another line on the same point, and then you form something called what? Called an angle. So basically, when you're talking about geometry, before you even start defining it together, you must know that you will be dealing with lines. You will be dealing with what? you'll be dealing with angles. Okay, so that is basically what you're going to be dealing with in geometry. And then these lines, you can have a line here and have another line here and then another line. Now these lines coming together, they can form what? A shape. Okay. Now this is another aspect of what? Of geometry, shapes. So we are now having lines, we are now having angles, we are having points, we are having shapes. So those are the things that you're going to be talking about in this lesson of geometry. Okay, now you are going to be saying something about these lines. So when you have a shape, so for example, when we talk about a shape, you can have something like this, like a triangle, because this shape has 1, 2, 3 sides. So it's a triangle. You can have a shape like this. Square. And many shapes. Right. So now in geometry, what are you going to be doing with these things? You are going to be saying things or saying statements about lines, about angles, about shapes. Right? So you are going to be looking at lines. You are going to be looking at what? At angles. And then you are going to be saying things about how they are related. So now if you combine all of these things and try to define what we refer to as geometry, it's simple thing that has to do with angles, with lines, and you are looking at a relationship that exists about these lines, which can then form shapes, and then you'll be looking at how you can relate shapes with each other, shapes with a similar kind of itself, and so on and so forth. So basically, in a fundamental matter, you are dealing with lines, you are dealing with angles, and you're simply dealing with how these two are related. So these two, when you combine them together, they give you something called geometry. Okay. Now that is basically what geometry is. It's just simple lines and what? And shapes. And then you're saying something about them. And lines and angles. So sometimes you'll be relating lines and angles. Sometimes you'll be relating lines with other lines. Sometimes you'll be relating angles with other angles. You will be mixing and turning things. You are just playing around with lines and angles. That's basically what you are doing in this beautiful subject called geometry. So what am I saying? I'm saying in geometry, you are going to be saying something about angles and lines. All right. So let us try and see one of things that we can say about angles or something that you can say about lines. Okay. Let's say we've got a problem like this one. This is a line. And then here I've got 60 degrees. That is an angle from here to here. And then I'm looking for this angle. Okay. And then here is my problem. It says find x. Okay, this is question 1. All right. They are saying I must find x. There is 60 degrees, so this x must be another degrees. All right. So how can I do this? Then when you look at your geometry notes or your geometry theory, you will find out that, okay, this is a straight line. All right. Okay, straight line. And then there are angles. I'm dealing with angles on a straight line. That is what I'm dealing with. Now the question is, what does geometry theory say about angles on a straight line? This is a question. And then when you look at geometry, no man, there is something that geometry says about angles on a straight line. Now, what is that thing? That thing is the sum of angles on a straight line equal to 180 degrees. This is what geometry says, geometric theory. This is what it says about angles on a straight line. Okay? Oh, okay. They are saying if I have a straight line and I have angles, so the sum, what is a sum? A sum is something plus something. Okay, so it means this plus this must give me what? Must give me 180 degrees. All right. Okay. Now, this thing that says the sum of angle on a straight line is equal to 180 degrees. What is it? We refer to this. It's a statement, and in this statement we refer to it as a theorem. Theorem. Right? Now, what is a theorem? A theorem is a statement that has been proved and could be proved as well to be true. Okay? This thing has been proved over and over that it is true. You can even prove it yourself if you want to. But this has been proved over and over, and it has been accepted as a fact in the world of mathematics that the sum of angles on a straight line is equal to 180 degrees. So, in geometry, we will have these angles, we will have these lines, and then we'll say something about them. But when we say things about those things, we will say it, and then those statements that we're going to say, we are going to be referring to them as what? As theorems. Okay? So, with every problem that you have, there will be a theorem that will tell you what is a relationship. Because now, for example, here, we're looking at the relationship between the angles on a straight line, and then we found that there is a statement that says something about the angles on a straight line, and then those statements, we call it what? We call it a theorem. So we are answering the second question. What is a theorem? A theorem is when you say something about some parts of what you are looking for here and what you have, and you're looking at the relationship between them. Okay? It may be angles and angles, maybe lines and angles and whatever, but if you are taking things and then you are saying, you are defining a relationship between those things, that is what? That is a theorem. So today you know what a theorem is. Okay? So now you know what a theorem is. Okay? Now, how are you going to use this theorem? That is question number 3. How to use a theorem. Okay? So the theorem says the sum. So what I'm going to do is I'm going to say, okay, x plus 60 degrees is equal to what? 180 degrees. Okay? Let me actually write it here. Can I please wipe here? Because I think it would be more beneficial for us if we write it here for some reasons. Okay? So we will say x plus 60 degrees is equal to 180 degrees. Okay, where do I take it from? I am taking it from a theorem. that says that the sum of the angles on a straight line is equal to 180 degrees. So how do I code these theorems? I can just say sum of angles. This is for angles. This is a shortage for angles on a SCR for straight line equals 180 degrees. Okay, this is how I show that I have used a theorem that says that the sum of angles on a straight line is equal to 180 degrees. Ladies and gentlemen, each and every teacher has their own way. Some teachers will say, okay, if you can just say sum of angles on a straight line, that is enough for me. Some, they want you to say equal to 180 degrees. So pay very close attention to what your teacher prefers so that you will be able to be aligned to that. Okay, so this is what this theorem says, and then I've used it here, and then here is where I show. Guys, now when somebody is marking, they will mark this, and then they will mark a reason. A reason has marks, ladies and gentlemen, personalities. Because this shows that you didn't just pick this thing from a tree, you didn't suck this thing from your thumb, but there is a theoretical background that you have that allows you to say things that you are saying. And that basically what has to happen in geometry. You have to continuously show that you do have something specific that actually guides you in terms of what you are doing. All right. And then because of that, you will then have something like this. Then when you are here, then x is equal to 180 degrees. And then you take the 60 degrees to this side and minus 60 degrees. And then 180 degrees minus 60 degrees, what do you get? 120 degrees. Okay. Now, this angle is equal to 120 degrees. So, if you put this 120 degrees there and you add it with the 60, you can get what? 180 degrees, which exactly agrees with what you are doing here. All right. So, where does everything start? You start with a problem, and then in the problem, you need to see what you are given and what you are looking for, and then you must be able to find a theorem, which is a statement that defines a relationship between what you are looking for and what you are given. And then use that theorem and then be able to show how you have used that theorem. That is what you do here in bracket. All right. So that is basically how you go about when you're answering geometry questions. So basically, let me put it in good terms, in a numeric form, so that you guys can see it properly, so that you are able to use it. All right. So what did I say? Solving geometry questions. Right. So how do you solve geometry questions? Step 1. Be aware of what you are. You are what? Be aware of what you are given. Guys, that's the first thing. You must know what is it that you are given. Number 2, what are you looking for? Okay. Guys, what are you given? That's the first question. Be aware of what you are given. Okay, it's not a question, it's a statement. And then secondly, what is it that you are looking for? What are you looking for? What have you been asked to find? And then number 3, what is a theorem? Theorem that combines one, that is what you are given, and two, that is what you are looking for. Like earlier, we did see that the law that combines what we are looking for and what you are given was what? Was a law that says that the angles on a straight line is equal to what? Is equal to 180 degrees. Right? What is it that combines 1 and 2? And then when we have found the theorem, then number 4, use that theorem and solve. All right. So if you can write these steps down, just like this, write them down. And then every time when you have a problem in geometry, just be aware of what you are given and what you are looking for. And then find a theorem that combines 1 and 2. That is what you are looking for and what you are given. And then use the theorem and then solve. But don't forget to quote the theorem. If you have used the theorem, do say that, okay, this is the theorem that I used, and this is what it says. All right? It is very important. Okay, let me look at a few other problems just to demonstrate this idea. I hope you wrote this thing down so that you can be able to refer to it. Right. Now let's see. Okay, let's find something to write here. Right. Write this down properly. Guys, we are winning. Geometry will never be a problem for us. So this is a structure, this is a methodology that you will take in all other problems in geometry, in every grade, grade 9, grade 10, grade 11, grade 12. If you follow this way, it will never let you down. Okay, let's see. Okay, let's say you've got something like this. Okay, and then, okay, let's make it a little bit bigger. Let's say I've got something like this, right? And then you've got 70 degrees. And then let's say that you've got, let's say 60 degrees here. And then you've got x here. Okay? And then they say find x. Okay? What are the steps? Step number 1. What are you given? All right? We are given this angle, and then this angle. Okay? And then this shape is what? Is a triangle. It's very important also to note the shape that you've been given. Okay, I've been given a triangle, I've been given angles, and then I'm looking for one of those angles. Okay, that is what I'm given, and then that is what I'm looking for. Okay, now next question. What is the theorem that combines what I'm looking for and what I've been given? If I look at this thing, there is a theorem. Now, guys, when it comes to geometry, you must know theorems. Okay, what I used to do when I was still a student, I used to write it down. I used to write those theorems down and paint them somewhere so that I can always look at them. Like when I look at them and then I start using them, they automatically become part of my system. So you must know theorems. But okay, if you want to cram them out, because some people work different, some people cram. If you want to cram them, you can cram them, no problem. But the best way to actually understand them is to write them somewhere and then start using them. And then as you use them over and over again, then you get used to them. Right? Okay. So there is a theorem there. The theorem says that the internal angles of a triangle are supplementary. Let me quickly write it on the side. The internal simply means, it's another fancy word that means inside. Internal angles of a triangle equal to 180 degrees. Okay. So they are when you add them, they give you 180 degrees. Oh, so you know now. Now this is a rule that combines all of these things. So you will then say 60 degrees plus 70 degrees plus this x is equal to 180 degrees. Why? Because of this theorem. Now you must quote the theorem so that you tell a person who is marking that I know my story, I know what I'm talking about. I'm taking this from a theorem that says that internal, I'll just say int, angles of a triangle equals 180 degrees. Okay? So a person who's marking will then mark, oh, okay, here's a statement, here is this. Okay? This is a direct translation of this theorem in a context of this triangle. Right? Okay? And then because of that, I will leave x alone. X will be here, and then I'll have 180 degrees, which is equal, okay? And then take the 60 to this side, minus 60 degrees, and then minus 70 degrees. And then my answer, if I have x minus 60 minus 70, what do I get? Okay? So if you have 60, 180 minus 60, you get 120. And then you minus 50 in that 120. You minus 70 in that 120, what do you get? You will get what? You will get 50. So the other one is 50 what? 50 degrees. Okay? What did you do? You looked at what you have, you looked at what you don't have, and then you look at the relationship between the two, which is defined in a form of what? In a form of a statement. And then what do we call that statement? We call it what? We call it a theorem. So basically, when you narrow everything down here, it narrows down to the following question. What is a theorem that can combine what I'm looking for and what I've been given? That is the only question that you're asking yourself when you're doing any problem in geometry. I've got something, I'm looking for something. How can I combine the two? What is a rule? Or what is a statement? Or what is a theorem that can combine those two? If you can answer that question, then you have answered everything. Then you will never have a problem in geometry. Because immediately when you find a rule or a theorem that combines what you have and what you are looking for, then you will find a way forward. Or you will find a way that will lead you to a way forward. Okay. So you can see from all of these things that the knowledge of theorem is compulsory, is non-negotiable. So if you want to run away from theorems, then you are in a bad place. Okay? You cannot run away from theorems. You must understand theorems. You must know them. You must know how to use them. Right? And you must write them down somewhere and then be able to use them. Let's see if we can find another good problem. Okay? Let's say now, let's say now we do have triangle again, and then we had this. $70, 70 degrees, and then we have this 60, and then we have x, and then we're supposed to find x. Question is, what do we do? Right? When you look at this thing, okay, I want to find x. All right. Okay, what am I gonna do? I've been given a triangle. Okay, there are angles inside. Okay, and then but now what I'm looking for is an angle that is outside, in the external part, in the exterior part. Okay, you know those keywords. Okay. Okay, so now what is a rule or a theorem that can combine an exterior angle or external angle with these two angles that I have, or one of them? Aha, there is a rule that I can think of. And what does that rule say? The rule says the exterior angle of a triangle is equal to the sum. Okay, I'm supposed to write it properly, but I'm writing sum of the opposite interior angle. Okay. So what does that mean in simple English? It means that if I have an exterior angle, right, I must look at the interior angle that is next to this exterior angle. And then I must just look at these two angles that are opposite it, that are inside. And then, so this angle that is outside is going to be equal to the angles that are opposite this interior angle when you add them. Okay? It says the exterior angle is equal to the sum. So this angle plus this angle is going to give me exactly this. All right. Okay. Write this thing down because I'm going to wipe it now. So then we can pause or replay and then write it down so that you can actually put it down and be able to use it. All right. So I'm going to say x is equal to 60 degrees plus 70 degrees. Why am I saying this thing? Because the exterior angle of a triangle is equal to the sum of opposite, up for opposite, interior, okay, angle. And then I'm going to put this on this bracket. Okay, the exterior angle of a triangle is equal to the sum of the opposite interior. Okay, I took this, I did not just suck this from my thumb, I took it from a theorem that says something about how these angles are related. And that is a theorem. Okay? A statement. I can prove it that it is true. Okay? So then 60 plus 70 will then give you what? Will then give you 130 degrees. So this angle is 130 degrees. Okay? And you can always check against other facts. Now, one of the beautiful things about maths in general is that some other facts are not suspended by the existence of other facts. So, for example, if you've got 130 here, whatever angle that is here, whether you use a rule, either rule, or a rule that concerns this or some other rule, then you should always get something that balances with other facts. What do I mean? For example, here I'm going to get 130 degrees. Okay, so 130 degrees plus this must give you 180 degrees. So this one is going to be what? It's going to be 50 degrees. Through using a fact or a theorem that says that angles on a straight line are equal to 180 degrees. So that fact holds for this. But let's say we did not know that fact and use the fact that the internal angles on a triangle must give you what? 180 degrees. 70 plus 60 plus 50 will then give you 180 degrees. So either way, it doesn't matter which rule you use or which theorem do you use, but if that theorem is a fact, it can always work. Okay, so the facts of mathematics, they work together. They all come together and work for good. Right. Okay, so it does not really matter sometimes. So for example, if you have this, if you have decided to find this angle through this rule, that will still be true. So this will be one way, or you can use the other way. It is totally up to you. Okay, as long as you use the correct rule, and then you are fine. Okay, now let's say I've got something like this, and then I've got x here, and I've got y here, and then I've got, say, 110 degrees here, and then let's say I have 70 degrees here. 70 degrees here. And then the question was saying find x and y. Okay, I've got angles, and then these angles are inside the vertical, the lines that crosses each other, and then this one is vertically opposite this one, and then this one is vertically opposite this one. Okay, now is there a rule that relates vertically opposite angles? Yes, there is a rule. Now what does that rule say? The rule says that vertically opposite angles are equal. Okay, so what does that mean? That means that x, because x is vertical opposite to 7, x is equal to 70 degrees. What is the reason? Vert for vertically, op for opposite angles. You are done. And then you say y is equal to this one, 110 degrees. Why? Because they are vertically. Vert for vertically, opposite for opposite. All right. So vertically, opposite. All right, guys. I hope that this did help. I hope that this will lay a solid foundation that you can actually build upon when you're solving your trigonometry problems. Guys, you can write these things down. I'm gonna wipe it out. So in closing, I'm going to give you a summary of these theorems because they are very important theorems. It does not matter which grade you are doing. If you don't remember these theorems, things are very problematic. You're gonna be in a state of trouble. Right? So theorem number 1 that I think you should remember. I'm not gonna write them in details. You can say important theorems. I'm not gonna write them in details. I'm going to put something nice Let's just illustrate them here. So important basic theorems. Grade 8, grade 9. These theorems are going to be directly examinable. Other grades, they will be indirect examinable. But you, grade 8 and 9, they will be. Right. Now, let's go. The first one, if you have something like this, and then you've got x, and then you've got y. X plus y is equal to 180 degrees. And then the reason for that is sum of angles on a SCR for straight line. Okay, that is number one. And then number two, theorem that I think you should remember: x, y, and then z is that x plus y plus z is equal to 180 degrees. Why? Sum of int for internal angles of a triangle equals 180 degrees. All right. A second very important theorem. And then 3. If you have C here, and then you've got x, and then y, C is equal to x plus y. What is the reason? It's because the exterior angle is equal to sum of opposite interior angles, and then close. And then lastly, number 4. If we have something like this, and then you've got A, B, C, D, then A is equal to C, and then the reason is vertically opposite angles equal, and then B is also equal to D. B is equal to D, same reason, vertically opposite angles equals. All right. Wow. Now this is it. These are 4 very important and very basic theorems of geometry, which lays a strong foundation for you to climb on and understand a little bit more detailed theorems, like time code theorems and all of those kinds of theorems. But if you don't understand this, you will be crushed, because they come out throughout every grade: grade 9, grade 10, grade 8, grade 11, grade 12, and even beyond that. So ladies and gentle personalities, thank you very much for tuning in. This is Mqondisi Macaba from Tembela Maths Club, and it has been a pleasure to work with you. And I think and I hope that you will enjoy your stay, and then you will be able to do things that you're supposed to do in geometry. Guys, I am going to produce more videos that are going to explain other important theorems as well and how to work out around them. And also I'll be picking different problems. I'll be picking different problems in different grades and then solve them so that you can actually see how they are solved. And guys, if there is something specific, which is not what I've mentioned here, that you have a problem with, you can always send me a message, or actually write down in comments. And also, if there's something that you didn't understand in what I was saying here, or something that I said that was wrong, please do comment around it. Or something that is not clear, please do ask in a comment section below so that I can be able to answer you. But ladies and gentlemen, thank you very much for tuning in. This is geometry for grade 8, and then it's also for grade 9, but also grade 10, 11, and 12 can use it for as a foundation. Thank you very much. Enjoy your day, and goodbye.